So for tangent and cotangent, again, they're going to follow similar rules, but the shape is going to be a little bit different. So for tangent and cotangent, the period this time is going to be pi. So let's break these down into pieces, and we're going to look at tangent first. And tangent has these breaks in it. Where it's undefined. So think about tangent. Tangent being sine over cosine, or the y value over the x value. And if we're looking at those quadrantal angles, then sometimes we're going to end up with something that's undefined. If you try to do 1 over 0 for 90 degrees, it's undefined. So it's going to have an asymptote there. So our breaks are asymptotes where that happens. So this is going to be a discontinuous function. So our sine and cosine graphs were continuous. You could use your pencil or your pen and you could follow that wave all the way across your paper forever and ever in both directions and not have to pick up your pencil. For this one, it's where it has undefined places, it's discontinuous. We're going to have to trace apart and pick up our pencil and trace apart and pick up our pencil over and over again. It also intersects the x-axis, kind of like sine does. So just like sine starts at the origin, tangent is going to intersect the x-axis at the origin also. So if we wanted to graph just y is equal to the tangent of x, let's look back at that unit circle one more time so we can get a little bit of a refresher where these values are. So remember, this is 0 degrees and my ordered pair is 1, 0. And this is 90 degrees and my ordered pair is 0, 1. And we know that all of these quadrantal angles, we can find those values for. Now, tangent is equal to the sine over the cosine. And remember, sine over cosine, that's the same thing as the y value over the x value. So for 0 degrees, the tangent, sine over cosine, 0 over 1 is going to be 0. So the tangent for 0 degrees is 0. Now we can find all of the values in between, but one that I want to make sure that we add in here is the 45-degree angle. So this is pi over 4, 45 degrees. Now remember the ordered pair here, 45, 45, 90, remember root 2 over 2. Your ordered pairs match, root 2 over 2, root 2 over 2. If we did sine over cosine for this one, it's going to be root 2 over 2 over itself, and anything over itself is equal to 1. So for 45 degrees, or pi over 4, this value is going to be at 1. Now what happens at 90 degrees? Well, 90 degrees, this is where that important thing happens. So pi over 2 is coming next. At pi over 2, if we do 1 over 0, that's an undefined value. So that's where my asymptote is going to be. See if we can draw that straight. So there's an asymptote. Let's move on. What happens if we get to, let's try 3 pi over 4 right here. So we're just counting by quarters. Or 45 degrees. So if we move on around here, this one's going to be negative root 2 over 2 and positive root 2 over 2. So that's negative 1. So this value is going to be down here in negative 1. 0 over negative 1 is still 0. Negative root 2 over negative root 2 is 1. And if we go on down to 270 degrees, we end up with negative 1 over 0 again, and there is another asymptote. And then here we're going to have a negative 1. That's a 4. And here we're going to have an intercept. So we've graphed from 0 to 2 pi all of those values for 45 degrees. If we count by 45, we've got all of those values here. Looking at this middle piece right here, this is the most complete. So we start here. This is going to, this is an asymptote, so I know it gets close to but doesn't cross that value. And this is an asymptote, so I know it gets close to but doesn't cross that value. So this is the basic shape of a tangent graph. So we could continue this pattern in this direction also. And we would have another one of those. And if we kept going in this direction, we would have another one. But notice from 1/2 pi to 1.5 pi, I've got one of those nice little squiggly shapes. And that's one period of my graph. So remember I said the period was pi. So it takes one whole pi to get one whole repetition of that graph. So if our A value is positive, then tangent rises as we go from left to right. So it looks like that. But in this case, if our A value is negative, then tangent falls as we go from left to right. So it just flips the direction. And our amplitude for tangent, notice how it goes up forever and down forever, so there's really no height here. The amplitude is undefined. So we don't have a value for our amplitude, not a defined value. Okay, what questions do we have so far? We're going to add on to this a little bit, but just on the basic tangent graph, what do we need to know? We good so far? Okay, so I feel like we might need a quick example for tangent. So let's do that next before we move on to cotangent. What if we have something that looks like y is equal to tangent of let's just do 2x. What if we want to do that one? Now, my general equation is still going to be the same. We've got y is equal to a times the tangent of k times x minus b, and then we could have a plus c. We'll use c for constant. So we've still got those same values. A, not technically the amplitude, but it tells me the direction if it's rising or falling. The k is still going to help me with the period. This is still the phase shift, and this is still the vertical shift. So we still have all of those pieces that we talked about before. So for this one, remember, a lot of times you're going to have all of these at one time. So it's going to say define the amplitude, the period, the phase shift, the vertical shift, describe the domain, the range, all of those things. So for this one, the amplitude for tangent, always undefined. The period this time, remember each period in our original graph is pi, so it's going to be pi over the absolute value of k instead of 2 pi over the absolute value of k. So in this case, it's going to be pi over 2 because 2 is my k value. So every pi over 2, my graph is going to repeat, so it's going to be skinnier than my original. For this one, we don't have a phase shift or a vertical shift. We didn't add one of those in, but we could have. Phase shift comes from the B value and the vertical shift comes from the C value. But we don't have either one of those happening here. So let's sketch this out. Now I don't have a phase or a vertical shift, so I know since I'm dealing with the tangent graph that it's going to go through at the origin. I also know that I have a width of 1/2 pi. So I'm going to have, if we divide half into another half, this is going to be negative pi over 4 and positive pi over 4. So a fourth plus a fourth is a half. So that's where my asymptotes are going to be. And my graph would look like this. Now, generally, as long as you're able to graph one of your periods of the graph, then it's fine. I usually like to do another one in this direction. So if we're counting by 1/4, this one's going to be pi over 2. This one's going to be 3 pi over 4. So this is where my intersection is going to be. And this is where my absolute value is going to be. We could split it up a little bit more so that we could see where these intermediate points are. So if we split it up again, we'd be counting by 8ths. But we can sketch these pretty accurately without that. But those should be at 1, -1. So that's what 2 periods of that graph look like. So it's the same as my original, but it's squished together a little bit. That's the only thing that we've changed. Okay. Okay, so let's look at cotangent. So cotangent also has breaks because tangent is sine over cosine. Cotangent is cosine over sine. Sorry, it's the opposite. So it's going to have breaks in the opposite places. So the places where tangent crosses the x-axis is going to be asymptote, and the places where there's an asymptote is going to cross the x-axis. So it's kind of like you've just taken that the tangent graph and shifted it over a little bit for cotangent. So this one also has breaks, also known as asymptotes, but we'll get there. And it also has a period of pi. And this one is the opposite. If the a value is positive, then cotangent falls from left to right. And if the a value is negative, think about it kind of like a slope, then the cotangent rises from left to right. Now, notice my squiggle doesn't look very good, but notice this looks just like the tangent graphs that I just put on there. So sine and cosine are the same thing, they're just shifted. So I could shift a sine graph and make it look exactly like a cosine graph. I could change a tangent graph and flip it around and slide it over so that it looks just like a cotangent graph. So they can match up if we need for them to. So if you're trying to write an equation for a graph that you already have, sine and cosine, you might have a version of each of them that would match the same graph. Tangent and cotangent, you might have a version of both of them that would match the same graph. So if it looks like there's repetition here and that one of them could match the other one, then you're right. It's just the nature of our trig function graphs. So let's look at cotangent. And now that we've done tangent, we'll be really good at cotangent. So remember, we just flip it over, it's going to be cosine over sine. Or we can look at that as my x coordinate over my y coordinate. So if we're looking at the unit circle again, at 0 degrees, the x value over the y value, 1 over 0, is undefined. So for this one, I start with an asymptote. So let's move on around. We're going to count by 45 degrees again this time. So we're going to do pi over 4, pi over 2, 3 pi over 4, and pi, then 5 pi over 4, 3 pi over 2, 7 pi over 4, and then out here we would have 2 pi. We're going to keep it going. So if we want to find that x over y, if we go to 45 degrees, remember those ordered pairs match. It's root 2 over 2 over root 2 over 2, so it doesn't matter if I'm looking at cotangent or tangent, they're exactly the same. Something over itself is always 1. So this value is going to be at 1. If we move on around, this is 0, 1. So if we do x over y here, we end up at 0. And then negative root 2 over 2 over root 2 over 2 is a negative 1. And then over here, we've got 0 over -1, which is undefined again. So notice I said that I was going to have one repetition, one period of my graph within pi. I said the period was pi. So from 0 to pi, that's one period of the graph. So if I trace this out, notice it looks just like tangent, only it's shifted over and backwards. We could keep going for another period. It's going to follow the same pattern. So that's what cotangent would look like. Okay, so let's do an example. What if we have y is equal to negative cotangent of x plus pi over 2 plus 1. So let's look at that as an example of cotangent. Now, my a value here is negative. K is still 1, so my period won't change. This phase shift means I'm going to move to the left pi over 2. And this vertical shift means I'm going to move up 1. So those are all of the pieces that I have to account for. So let's label this out. Remember, we're labeling all of this. My amplitude is undefined. The period is pi over the absolute value of k. So it's going to stay pi because k is 1. So I could do pi over 1 or just pi. I've got a phase shift, pi over 2 to the left, and a vertical shift up 1. So let's sketch this and see what we end up with. So if I were just gonna graph the cotangent graph, remember cotangent, I'm gonna do my original in pink. This is at pi. So this is the original. Now we're gonna keep the width of it the same, but we have to shift it over half a pi. So I'm gonna take each one of these asymptotes and move it over half of a pi. So this asymptote's going to move to the left half. This asymptote's going to move to the left half. And each one of my points is going to have to move to the left half of a pi also, but I also have to move them up 1. So if I move to the left half a pi, that puts me at 0, and then up 1, this point has moved here. This point's going to move half a pi and up. This point's going to move half a pi and up. So this is what it looks like now, but now I have to flip it around. It's going to be increasing because my A value is negative, so these points are going to trade places. It's going to be increasing from left to right. So basically, my slope has changed. So instead of decreasing from left to right like the original, now it's increasing from left to right. Now, look at the graph that I have. If we shifted it down, if we hadn't done the shift up, it would look just like that cotangent or that tangent graph that we did at the beginning. See how it's rising from left to right? It crosses the y-axis. It has an asymptote at negative pi over 2 and at pi over 2. Same thing here, only we've shifted it up 1. So instead of crossing at the origin, it crosses at 1. But we've manipulated that graph so that basically it looks like a tangent graph that's been shifted up 1. So we could have described that graph either way, but since it's a transformation of my cotangent graph, I had to go through all of those steps to make the same thing. Okay. Okay, so that covers all of tangent and cotangent.